Welcome to another AgGateway Global Network video. I'm Jim Wilson, President of AgGateway Global Network, and with me is Andres Ferreyra with Ag Connections. Andres will discuss AgGateway core documents for field operations. Andres, please tell us what you do for Ag Connections and AgGateway, and then move into your presentation.
Thank you, Jim. Hello, everyone. My name is Andres Ferreyra. I am Manager of Special Projects in Ag Connections. Ag Connections is a farm management information systems company. A lot of what we do pertains to bringing data in through various integrations with other hardware and software systems to enable growers to keep track of what they do, what the costs of what they do are, to help them with regulatory reporting, and so forth. And it's generally very hard to maintain integrations done point to point with an increasing number of integration partners. So we have a very strong motivation to support AgGateway's work towards implementing standards where we could integrate once to the standard and thus have access to integration with many partners. And one of the things that we have worked on for a long time then is this process of recording field operations that growers go through every year. The problem is that modern farming increasingly demands of the grower detailed records of their field operations. When they go plant, they have to say what they planted and where they planted it. When they're spraying a crop protection product, they have to keep track of restricted use pesticides. They have to keep track of the load of the different active ingredients that are placed in different parts of their land. They also increasingly have regulatory compliance requirements pertaining to the application of fertilizers. And if they're participating in crop insurance or other programs that are linked to their harvest, they need to keep detailed track of that as well. So the motivations then are on one hand regulatory pressure, and on the other their role within a supply chain demands it as well, whether for basic commercial purposes or for more contemporary needs like traceability and sustainability and the documentation of that. So the growers and the partners they have in these processes use these multiple documents to exchange information about their field operations as part of their business processes. Now, we haven't been able to find any kind of standardized set of those documents for field operations. There has been work done in standardizing the list of processes themselves, and there's a standard called ISO 22006 that has an annex where there's an interesting list of processes. But the documents that are used to support those processes have not been unambiguously defined. And that's one of the tasks that AgGateway's Spade and Pail projects have worked on. And we'll have separate webinars on the work done in Spade and Pail. But I just wanted to show you as an indicator of how representative the knowledge that is contained in our deliverables is. Just a list of participants in both Spade and Pail. This is a combined list of companies and individuals that have participated in these two projects. So you will see machinery manufacturers, you will see manufacturers of different kinds of crop inputs, crop nutrition, crop protection, seed. You will find companies that provide reference data. You will find companies that provide farm management information systems. You will find companies that help growers process information and derive value from it, and so forth. So, going straight to the documents. At this point, we have discovered 5 core documents. A plan, which is a strategic document where the grower says this is how we're going to grow this crop this season on a given area of land. And then a set of tactical documents that may be created multiple times in a season, which start with observations and measurements, where either people go out in the field to make observations or observations are brought in from sensors. But essentially, we're trying to establish what is happening out in the field. Then somebody with expertise will take that information and take the plan and say this is what they recommend be done about the state of the field. Then out of that recommendation, someone with authority will determine what is going to be done, and that is expressed through a work order. And then the work record is an expression of what was actually happening out in the field. I'd like to point out that there is a huge diversity of level of detail with which these things are implemented by different growers. It may happen to be a set of ideas in the grower's head, or it may range all the way to an extremely detailed set of records in the database of a farm management information system. So we kept that diversity and that different granularity very much in mind as we were working on this. Let's look at how these core documents are related. So we see in these dark boxes are 5 core documents. The plan, which motivates these observations and measurements, informs the recommendation, informs the work order, and then you see this loop here where the observations and measurements inform the recommendation, which informs the work order, which motivates the field operation itself, which in turn is represented by the work record, and the cycle begins again. You'll note that the plan informs the recommendation and the work order because the plan may provide constraints for these things in that perhaps given certain market conditions at the time, the plan may be to only be able to do a certain number of, for example, fungicide applications to a fruit crop. And the work order, where the person with authority, be it a farm manager or somebody like that, or the grower, decides to do the field operation, may depend on the constraints of that plan. So perhaps an agronomist recommended an additional fungicide application for agronomic purposes, but if there is not money available for it as laid out by the plan, then that field operation would not happen. Now, you see in the middle, there's this idea of reference, setup, and configuration data that is providing context for everything else. How does it do that? Well, let's first quickly discuss what these things are. And we'll have a separate webinar on these things later on. But for now, let's imagine that reference data provides information about all the different possible instances of a thing. So, for example, if we're talking about a crop protection product, the reference data about that product might give you a unique identifier that you can use across your system. It might tell you the name of that product. It might tell you what the different active ingredients contained in it are and their concentrations. So all the things that would be common to every single bottle or jug of that product X. For equipment, reference data may pertain to the brand, series, model, and other things that are common to all instances of that tractor or harvester. Then setup data is data that pertains to one particular instance of a thing, although independent of its state. So you might say that for a piece of equipment, setup data might be, for example, its serial number. So it identifies a particular instance of a thing, but it doesn't tell you what's connected to what implement it might have, things of that sort. So configuration data would be the information about a particular instance of a thing in the context of its current state. Think of, for example, a soil water sensor where it tells you where the sensor is installed, at what depth it's installed, what data logger it's connected to, and so forth. Okay, next slide. The documents rarely stand on their own, right? We just saw about these relationships, how they motivate or inform one another. So it's clear that the documents exist as part of this complex network of decision-making within the grower's operation, and our intent was for the documents to reflect the data requirements of those corresponding processes. So if you are making a recommendation, then the recommendation core document should contain all of the data that is needed to communicate that recommendation of a course of action. A work order would contain all the data that's needed to communicate what needs to be done in that field operation. For example, the work record would contain all of the data needed to document what happened. And we recognize that the relationships among different core documents might be different. So we came up with a little taxonomy of these relationships: causal, contextual, and compositional. And we applied them also to other documents we are starting to work with that can form part of or have relationships with the core document. So causal relationships are, like we saw in the slide a moment ago, where a recommendation can inform a work order or a work order can ultimately motivate the work record. A contextual one is, for example, where the product label of an insecticide can help identify that product used in a work order, or it might provide additional information for planning that operation, like personal protective equipment is needed by the operator. And compositional is when you might have, for example, photographs or sound files that you want to include along with a scouting report or other observations and measurements document. Now, we saw that the core documents can have all these relationships. Well, let's see how they can flow among different stakeholders. So let's start with the grower. Let's imagine that grower is working with an advisor with some service that will provide scouting or other data sources, a service provider that may spray the crop or harvest the crop, and other destinations for data that the grower will produce. Let's think about these partners. So the grower would want to send the plan to the advisor, for example, and send the plan to the crop scout to get them to initiate their processes. The crop scout will start observing what's going on in the field and producing data that will then be shared with the advisor. Now, the advisor also got history of work records and observations and measurements from the grower. And seeing what has been done before and looking at the observations and measurements that have just come in, the advisor may make a recommendation to the grower. Now, it's important to note that these flows can also be a little bit back and forth. The grower could say this recommended course of action is too expensive, for example, make me another recommendation. So that arrow shows us how these can be bidirectional flows. The grower, having accepted a recommendation or decided a course of action based on the recommendation, send the work order to the service provider. Service provider performs the field operation and sends the work record back to the grower. The grower will process these records in their farm management information system and send various derived reports out to regulatory agencies and their data partners. Again, these flows may be implemented in multiple ways, about as many ways as there are growers again. Some of these flows may be done over the phone. Some of them might be done with an ad hoc form that gets faxed or through an email. And a lot of what we did was try to understand the data requirements and look to formalize them in a way that we could then use to reduce error and to help standardize these flows. Now, the content of the different documents, data content, is actually quite similar. We found that what they contain tends to all be the same set of questions or answers to questions along the lines of what are we trying to do, where are we trying to do it, who's going to do it, how is it going to be done, when is it going to be done. Levels of detail may vary. The plan will probably not mention particular operators, for example, or maybe even specific fields. But an important thing about these documents is that despite their similar data content, they differ very much in their intents and contexts of use. And we believe that we're going to extend our set of documents starting fairly soon. And some of these extensions are going to be hierarchical. We're going to specialize the plan and have seeding plans, manure management plans, irrigation plans, and so forth. And then also have a set of supporting documents, which are essentially sort of a combination of verbs, if you will, like requesting something, acknowledging that you received something, or canceling something, and so forth, with nouns like these different documents. And for that, we have been looking at the OAGIS list of verbs, which are a very interesting starting point for us. We're in active conversations, an OAGI group, about using their list of verbs, consistent with AgGateway's desire to collaborate and reuse existing work as opposed to trying to reinvent our own. So what data is contained in the core documents? like I said, answers to a set of questions. So, for example, what are the products or services being applied, or the data that's being reported? Where are we trying to do this? So we've defined a grower, farm, field, crop zone hierarchy, and we enable the tagging of a document with the appropriate aspects of this tree that fit. We can also use GPS locations where appropriate, for example, in determining the precise location of a sensor, or when bringing log data back from an agricultural machine that was collecting multiple points in real time, be able to report accurately where each little particle of yield or as applied product happened. Also capture who were the people involved and what their roles were. Capture the names of people, and also capture what they were doing. When should this field operation happen, or when did the operation happen? We have created a list of meanings for dates, and we allow tagging any document with a list of these things we call time scopes that are either timestamps or time intervals that are bundled along with an enumerated value that says what it means. Was this an approval date? Was this the start and end date time for an operation? What was this? So we have a controlled vocabulary for that. Then how was this done? So the product rates, the equipment settings, all of those things that will allow us to accurately represent the field operation, and especially to be very accurate with mass balance of applied products, whether they be fertilizers or crop protection products and their active ingredients, or, for example, irrigation water. What equipment was involved as well, with various levels of detail. And we will see all these things in their implementation and ADAPT in far greater detail in a future webinar. Also, we enable tagging the documents with the reasons for performing the operation. Already in various jurisdictions around the world, you have to embrace some kind of integrated pest management strategy, for example, where if you're going to spray for a crop, or even if you're going to fertilize your crop, you have to document what was going on that enabled this operation, whether the presence of a pest or some kind of nutritional deficiency. So this goes back also to documenting those relationships, as I mentioned earlier, and being able to associate observations and measurements that informed a recommendation, for example. And finally, context item, which will also be the subject of another webinar. This is a generic system to associate geopolitical context-dependent information and attach it to a document. For the United States, this might be an EPA number for a product, USDA Farm Service Agency numbers for the farm and the fields and the crop zones, Department of Transportation numbers, and so forth. For Europe, this may involve, for example, commodity codes used in different countries to list crops and have those IDs available for regulatory reporting. Now, we have made this generic so that we can encode pretty much anything from any geopolitical context and not include it, not hard code it into our data model, but rather enable a data-driven approach where different participating companies or users of the data model don't have to update their software every time that we want to add something to enable somebody somewhere to make a new regulatory report. Instead, the data model remains the same, just the list of available geopolitical context item definitions is expanded, and you can read that from your farm management information system. So, a few final discussion points. We believe that this work has legitimacy in that it emerged from a large multitude of actual user stories. We asked many different growers, large growers, small growers, what sort of information they had to capture or what information they used in order to drive a decision. We're certainly open to more user stories and more use cases that can help extend this to make it applicable to a larger number of growers. That being said, an important aspect of this is that we recognize that very wide range of granularity in the usage of these documents across the industry and farm management information systems. It range from very detailed to very broad, and we believe that we have captured those different possibilities in our work. We also think that the work being done here by these AgGateway groups is enabling more principled decision making. We're hearing from our customers that they are being asked to record the work they're doing and record their decision-making processes. And that unsupported, that is quickly becoming an overwhelming amount of work for them. So by providing this framework, we want to believe that users of farm management information systems that use the core documents and the implementation of these core documents in ADAPT will be able to handle this within the framework provided. There's also very strong implications here for reporting of traceability, sustainability metrics, and so forth, because we have ways of communicating all that. Both what was done that drives traceability and sustainability calculations, and also to be able to accommodate the results. For example, sustainability metrics themselves, along with the data model. We think that our emphasis on semantic interoperability and using controlled vocabularies and other semantic tools is going to translate into greater data quality as participants in the supply chain and data exchange partners can be assured that the data being exchanged means the same thing to all of them. And we think that this will lead to greater data exchange in agricultural field operations and the simplification of that data exchange, which is, again, a recurring theme that we, and by we I mean the participating companies in these projects, hear from our customers on a day-to-day basis. And we also think that this will enable greater usability of research data. On one hand, because it will make it easier for researchers to have access to lower cost, highly usable data such as sensor networks and so forth. Also, if the researchers can adopt some of these controlled vocabularies, that will enable their data to fit right into this framework. And finally, it also provides a way, especially through the context item system, which, like I said, will have its own webinar. It enables making controlled vocabularies that have come out of the research community widely available to practitioners in ways that haven't been there before. So some of our next steps, the observations and measurements document needs a little work. We have some very active work being done right now, aligning with the ISO 19156 standard on observations and measurements, which is a standard done jointly by ISO's Technical Committee 211 and the Open Geospatial Consortium, and which happens to be one of those rare instances of an ISO standard that is available free of charge. So if you're interested in that, please go look it up on your internet search engine and you'll have access to that. That's a very interesting document that we're trying to align with. We're also looking at standardizing report specifications, so as to be able to develop a library of report definitions so that different users can all produce the same kind of output for, say, an FSA 578 report of planted area. Well, we want to have a library essentially of schemas for each one of these reports that we can share. And we're also looking to develop interactions with supply chain documents and with supply chain processes that field operations touch. For example, enable the integration with inventory management. As you put a certain number of liters of a product in your tank, you can remove that from your inventory and be able to map the kind of container that you're using and so forth. This kind of information, supply chain information related to products, is currently handled in AgGateway through a tool called AGGAS, which has a very comprehensive controlled vocabulary of different available product packages and the identification numbers for them. So we're looking to develop a system to enable linking that to the reference data system that we're developing for field operations that will contain field operations required data like the active ingredients and those things that I mentioned earlier.
Thank you, Andres. Well done. And thanks to all of you who are interested in learning about AgGateway, its activities, and its resources. Be sure to check out other videos in the AgGateway Global Network video series. Take care and goodbye.